Here, we're going to look at an important problem that has a deep connection with integrals, which we will be studying very soon. So, suppose my velocity is given by v of t equals 4t minus 6 meters per second. What is my displacement on the interval 2 to 5? Now, if you haven't heard the word displacement, this is just asking the net change in my position, or if my displacement is given by, let's say, s of t, this is, if my position is given by s of t, then displacement on the interval 2 to 5 is the net change, which would be my position at 5 minus my position at 2. Now, it would be lovely if we had the position function, but all I was given was the velocity function. But we do know one thing. Position is the antiderivative of velocity, which is another way of saying that velocity is the derivative of position, which is like one of our key Calc 1 facts. So we can find, and I'll put an asterisk here, the position by taking the antiderivative of velocity. And thankfully, our velocity isn't too bad here. So we have a velocity of 4t minus 6. That would give us a position of, using kind of that reverse power rule, that would be 2t squared minus 6t. Okay. Now, there's an asterisk here because we took an antiderivative. There's actually an additional constant here, and we don't actually know what that constant is, and we weren't even given any information that would help us find that constant. But it turns out that constant won't affect our displacement. So I'm going to do something here which I'm not really ever going to do again, but just for the sake of argument. Remember, we want to find the displacement on the interval 2 to 5. What we can do is we could just leave that constant in there and see what happens. Well, what's going to happen? I'm going to need to find s of t, or s of 5, minus s of 2, which is going to be 2 times 5 squared minus 6 times 5 plus c minus 2 times 2 squared minus 6 times 2 plus c. And I'll evaluate these things soon. But before that, I'm just going to distribute the negative and see what happens. And when I distribute this negative, that's a plus sign now, I see that these constants c are just going to cancel out. So when taking displacement, we can ignore the plus c. So from here on out, when you're doing a displacement problem like this, you don't even need to write the plus c here. It's just going to end up canceling out when we do the displacement, so it's not needed. So with that, let's go ahead and finish calculating this. We have 2 times 5 squared. That's going to be 50, 2 times 25, minus 30. Plus c, but that canceled out. Minus 2 times 4, that's minus 8. Plus 6 times 2, that's plus 12. That's going to be 50 minus 30 is 20. Minus 8 is 12, plus 12 is 24. This is displacement, so my units are going to be meters. And this means I moved forward 24 meters between 2 and 5 seconds. So there's a little bit about displacement, and again, these displacement problems are going to be very relevant once we start looking at integrals more closely.